Today we're going to talk about transformations of polynomial functions. So if you think back to transforming functions earlier in the year, tell your neighbor what you remember about transforming them. Okay, can I get your attention up here, please? Yes, not those type of transformers. All right, no Optimus Prime in this one. Okay. Yeah, I know. So transforming, we are doing what to it? We're moving it. We're moving it up, down, left, right, flipping it over axes, over lines. Okay, we're moving it around. Okay, so it's helpful to remember this form. Y equals A times x minus h plus k. Now that's a very, very generic form, but it helps us, and this doesn't really deal with too many of the, it doesn't deal with the horizontal stretches or shrinks. It only deals with the vertical the way I have it written out. If we're dealing with the horizontal, we got to do some other stuff inside the parentheses, which we'll get to, okay, a little later. But for now, what does k do? It moves it up or down. Up if it's positive, moves it down if it's negative. Okay? Remember h. Moves it this way if it says minus h. It moves it that way if it says plus h. Moves it left and right. Sorry, that's a little smaller. There you go. And what's a? Does it deal with a change in your y on your y-axis or your x? Is it vertical or horizontal? It's vertical because it's outside of the parentheses. Anything that happens horizontally goes on the inside. Vertically, remember, is on the outside. So this is, it deals with a shrink vertically, or a compression, or as this book likes to call it, it deals with a stretch vertically, or this book calls it a shrink vertically as well, rather than, a lot of books will call it a compression vertically compressed, which means you're pushing it down, all right, towards the x-axis. But remember that it's kind of like your gas pedal. The higher the number, the faster it approaches infinity. So if it's a big A term, it's going up really fast. If it's a small A term, it's going up slow. Okay? And when I say small, I'm talking relative to the number 1. So if it's bigger than 1, it's going up faster than the parent function. If it's smaller than 1, but greater than 0, it's going up slower than the parent function. It's making it wider. Okay? The last thing, if you talk about, well, let's write this out. This is a shrink. I'm going to use the textbook terms here. Shrink and stretch. Once again, shrink can also be called what? Can be called a compression. Okay, a shrink and a stretch. Okay? Yeah, it's supposed to say stretch. It shrinks when A is between 1 and 0. And it stretches when A is greater than 0. Or greater than 1, excuse me. What happens if A is negative? So A is less than 0, so you may think of it as a negative value. What's it do? Yeah, it doesn't go up, it goes down. It reflects it over the x-axis. Reflect. I'm stuck in geometry mode there. Reflects it properly. Reflect over x. I hope you gave yourself a little more room than I did. Hopefully you're taking notes on a note page. Okay? That's really getting cramped in and ugly there. Okay? Reflect over the x-axis is what it says there. Okay? All right. So you can add that to your note page. You don't have to write it on top of this page. Okay. Now, let's talk about, or actually, you guys go for it now. You have this page. Write your functions, given those graphs. All right, let's see how we did. So this is the function f of x equals x cubed. That's our parent function. And they want us to write these in g of x form. So if I look at option A, if we kind of focus in on the point where it turns, okay, or it slides through the graph there, if we focus in on that point, what has happened to that point? Shifted to the right too. So we write that as, is it going inside or outside? Inside. So when we say inside, it's going inside with the cube there. So that's x minus 2 cubed. Okay? If it happens on the inside, it's moving left or right. Okay? This one doesn't happen on the inside unless you think of it as reflecting over the y-axis. Okay, so if you look at this and you're saying, well, this point that was here moved over to here. And this point that was here moved over to here. So now I have this function that does this type of thing, which is what that is. Now some of you maybe thought of it this way. You said, well, that one actually moved down here. And that one actually moved up there, which means it reflected over the x-axis. So you can kind of think of it in two different ways. If you said, well, g of x is equal to, I took and reflected it like that, that means I reflected over which axis? Yeah, I reflected over x. It changed vertically. Okay? What does that simplify to? Yeah, it just simplifies to negative x cubed. Okay, well, what if you reflected it horizontally? That would actually have been, if we said the negative would actually have to go on the inside. What does that simplify to? Yeah, negative times negative is negative x cubed. So they're both the same, no matter how you decided to write it. Okay? All right. Any questions there? Okay, this one, the point did what? Shifted up to g of x equals x cubed plus 2. On the outside there. Okay, it's not coupled with anything. And this one shifts up 2, down 1, g of x equals right. Any questions? Okay, not too bad. Okay, try exploration 2. We'll make it a 4th degree. Okay, just to make it a little more fun.
McCoy, I think you and I have a very different definition of fun. Almost exactly.
No way, man. All right, let's check this one out. Just the bottom piece right here, we're focusing in on it, was at 0, 0. It is shifted to the left 2, or to the right 2, and down 2. So g of x equals x minus 2 to the 4th, all minus 2. And this one shifted over 2 and up 2, so g of x equals, yeah, it flipped also. So we got to put the negative out on the outside. So x all right, the negative's on the outside because it flips vertically. It's affecting it vertically, so it happens outside. Horizontally happens inside. Okay, how many think you got it? All right, I want you to take a look at the next page of your student journal. All right. Now, guys, this is just a summary of our transformations again. Now, the ones that we did not talk about today, we did not go into the horizontal stretch and shrink. But remember, that happens on the inside here. If it's 2 on the inside, it's kind of counterintuitive on the inside. That means it's actually shrinking by 1/2. And it's shrinking away from the y-axis. Okay? If it's a 1/2 on the inside, it's stretching by 2. And it's stretching away from the y-axis. Okay? So it's kind of backwards on when it's happening on the inside. I did. You have it. It's in the. You had this in chapter 1 and 2. I promise. It's in your journal. It may just not have the 4th powers. It has smaller powers. Yes. Not as powerful. Sometimes. Yeah. Okay. Here's what I'd like you to do. Go ahead and take a look at page 109. Let's try some of these together. Just so you know your assignment today, your assignment is going to be page 109 and 110, 1 through 7. Okay, now you may take that 2 different ways. You may like, oh, dude, 7 problems, all right. Or you may go, hold on, there's only 7 problems. What's up with that? Okay? So I will tell you it's kind of a mixture of the 2. It shouldn't take tons of time. And there's no big trickiness in there. And I don't want you to spend all weekend on it. All right? Now, with that, looking at this page, they don't give grids on here. I will tell you, after kind of looking at it, that almost all of your grids will work perfect if you just split them down the middle like this. I did say almost all of them. That means number 6 is the one that will not work perfect. I would shift number 6 so that it's split. If you're doing the grid for 6, I'd put it more like this. Now you would probably figure that out, but it would take you a little longer, and I'm not so worried about the scale. I'm finding the scale right now. Or excuse me, figuring out exactly where to put the grid lines. We will work on scale a bit. Okay, I want to do number 1 with you. Maybe talk real quick a little about number 2, and then off you go. Okay? So number 1 is x to the 4th. X to the 4th, tell your neighbor what the end behavior is. Good. End behavior is up, up. It's going to start up here and end up here. It has a 4th degree. Notice that we're graphing 2 different functions on the same grid. We're graphing a f and a g. Okay? F of x equals x to the 4th. It doesn't shift from the vertex. It has no hk. So if you're going back to this format, that'll work for almost all of these. Which one will it not? It'll work for this one, right? Which format will this not work for today? Or which do we need to add to it? Yeah, it's 4, right? Okay, and it's 4 because this has a horizontal stretch on the inside. Okay, now you can easily get rid of that if you want to cube it and just make it vertical then. So, Emily, that's the question you just asked. You said, hey, we talked about this earlier in the year. We said sometimes the horizontal and vertical, they can go together. Well, if I cube, right now this is a horizontal stretch of 2. If I cube that, that becomes 1/8. It's now, the other way to think of it is g of x equals 1/8 x to the 3rd. It is now a vertical shrink of 1/8. Horizontal stretch of 1/2 or of 2. Well, the question that you had asked, at least to me, made it sound like, could we just interchange those 2? Like, okay, yeah, that will work. Yes. Okay. All right. So you could go out like that. Okay. But that's not where we were. We were right here. All right. So what's my vertex? 0, 0. Okay, now notice I'm using pencil. I've started using pencil, and there's a reason for that. Here's what I expect when you're graphing. I expect you to go one place to the right and to the left of either the vertex or the turn. Okay, so the vertex on an even degree is your turn. In an odd degree, like x to the fifth actually has a slide in the middle, right? So when I say go one place to the left and right, I'm saying go 1 unit this way and calculate the correct value for that function. Go 1 unit this way and calculate f of x for that function. So on this, I'm saying go 1 unit to the right. So that means if I'm going up by 1s on x, x is 1. Well, when I plug 1 in for x to the fourth, what do I get? I get 1. Notice I'm using pencil. Okay? When I plug -1 in, I'm going to get? I get 1. Anytime you plug a negative in and you raise it to an even power, you get a positive. Okay? Now, that's fine for this because I could keep going. I could even plug in some more numbers, but I only require 1 unit to the left and right today. Okay? It's just when I plot g of x, so everyone cranking out the answers now, g of x is going to take f of x, which is that, and it's going to do what to it? It's going to drop it down 9. Well, can I go down 9? Not in my current scale, I can't. My current scale, I'm going up by 1. Or, excuse me, with this, the interval that I have is going up by 1. I should probably go up by 2, which means I'm going to define this as 10 up here, which means this is no longer right there. It is right there. Okay, that's why I used a cool pencil. Now notice, if I go out to 2, I'm like, you know what, I'm going to overachieve today. I'm going to calculate 2. Well, 2 to the fourth is 16. Does it make it? No. So you can't overachieve unless you use a separate sheet of paper. Okay? Now we can go drop it down 9. This point drops down 9, which is right there. Okay? This point drops down 9, which is right there. And this point drops down 9, which is right there. Okay, now I'm going to sketch in my graph for f. Notice I do not cross x equals 2 because this graph does not cross x equals 2 until you get up to what number? 16. And I'm going to label that f. All right? This one, now if you want to overachieve with g, you could. Go over 2. And, well, 16 minus 9 is 7. Now, do you have to? You don't have to. I didn't say you had to on this one. You only have to calculate 1 over. But if you are going to cross this line, x equaling 2, with your g graph, you better overachieve. Okay, you better actually calculate where it crosses. Otherwise, you should not cross that line. Like as soon as I got up there, I decided to curve the line. Did it again. Unbelievable. What is going on? And we will label that G, and I'm going to label it down here at the vertex and call it G. G will occur. By golly, we got it. Gee whiz, yes.
So you said go over 1 unit since the scale? Oh, never mind. You just changed it.
Yeah, that's a good point. Hey, I only changed the y scale, right? Or the f of x scale. I didn't change the x scale. Okay. Any questions? All right, there you go. Off you go.